Good morning. Second to last day. I'm not counting Wednesday. It's good to communicate with all of you. I was going to say good to see you, but of course. Just a couple more days. I'm trying to make these days as easy as possible. Now, today it is our last promo Tuesday, and fittingly, today we are sponsored by probability and stochastic processes. I kind of focused on this area of math in college. Still don't have a great understanding of it. It's pretty wild once you get up to the higher levels of probability, but it is quite fitting that this is our last promotion. You know, like, what's the probability that you're going to pass my class? So promo code is down below. It is stochastics. I'll let you see how to spell that down below. And that'll take 30% off your order or 5% off your order. It's 50-50. Now, pre-calc, we do have one last day of math for you coming up. So go on ahead and leave us now. All right, happy Tuesday. Last day on math for the year. For some of you, this is the last math I'll ever teach you. Very sad. But of course, for many of you, we'll be continuing on to AP Calc, so we'll review all of this again in the fall, but I'm so ecstatic that you get a taste of all of this now. Let's jump right into part C. So we're continuing what we did yesterday with the same definition. Now, the last 4 problems on this page work a little differently than the first 2, which is why I definitely want to make sure to go through the first one with you, and then you should be able to try the other 3 and check your answers with me. So here is the function that we're given. Now, for this particular piecewise function, we actually have a single function for all but one x value. So it's not like we have 2 different intervals. It's just everywhere except one particular x value. This is our function. And at that x value, at x equals 3, we're told that our function is some constant. Now, we don't know what that constant is. It's b. Now, if we were to graph this, it's a rational function. Okay, so we could go through the trouble of simplifying it, finding any holes and asymptotes and graphing it. Now, if we do, we would see that it's actually a linear function with a hole where we canceled this at x equals 3. So in order for the function to be continuous, okay, that's really what this question is, what value does b have to have in order for that function to be continuous? In other words, what value for b would remove the discontinuity? Okay, that's what most of these problems will be asking. Luckily, we don't even have to worry about graphing it. We don't need to care about what the function looks like. We have this definition. So the limit, and we're considering c equals 3, right? That's where the function could be discontinuous. That's where we're trying to plug or remove the discontinuity. So the limit as x approaches 3 from the left of f of x, what does that equal here? Well, to the left or to the right of 3, x doesn't equal 3. So this top piece is to the left and right of 3. And then the bottom piece is at 3. So the limit as x approaches 3 to the left of f of x equals the limit as x approaches 3 to the left of, we're looking at the top piece. We try plugging in 3, but we get 0 in the denominator, which means we need to do some algebra magic first. The numerator factors, it's a difference of squares. X minus 3 cancels. We have the limit as x approaches 3 from the left of x plus 3 over 1. And now we try substituting. We get 3 plus 3, which is 6. Limit as x approaches 3 from the right of f of x is going to be the same thing. Okay, the limit as x approaches 3 from the right of x squared minus 9 over x minus 3. We try all the same steps, and we get this equal to 6. So the limit exists, but what is the function value at 3? When x equals 3, which piece of the function are we looking at? The second piece, which is b. Now, f of x is continuous if and only if limit from the left equals the limit from the right equals the function value. And what is the limit from the left? That's 6. Limit from the right is 6. And the function value is b. So what does b have to equal to make this function continuous? Well, it has to equal 6. Okay, so same steps. Just requires a little more thinking at the very end here. We need to set those three things equal to each other and then actually solve for this value. Okay, hopefully I haven't lost you. Again, we'll be talking about this again in calculus, but I really want you to have seen this before, so the start of calculus isn't quite as difficult for you. All right, let's talk about, so go ahead, try D, E, and F, and then come back and we'll go through those answers here. So part D. I'm going to try a different marker here. This one's starting to run out. Here is our function, piecewise like usual. Note that this definition of continuity works for any function. It doesn't have to be piecewise. This is actually how we prove that other functions are continuous everywhere. All right, now where is this function split? At 2. So we're considering c equals 2. The limit as x approaches 2 from the left of f of x. All right, that's going to be the top piece. And you don't have to label it here like I do. I just find it helpful, especially since this is a newer concept for you. So to the left of 2, we're considering the top piece. We plug in 2. Trying substitution, we get 2 squared minus 5 times 2 plus 3. So 4 minus 10 is negative 6, plus 3 is negative 3. Right, now we try the limit as x approaches 2 from the right. That means we're looking at the bottom piece of this function. Plug in 2 for x, so we get 2 times a plus 1. That's as far as we can go there. And then finally, f of 2, which piece includes x equals 2? The top piece. And like we calculated before, that's negative 3. Now f is continuous if and only if these three things are equal. And what do we have for these three values? Negative 3, 2a plus 1, and negative 3. Now, if you do these correctly, okay, we have three things setting them equal to each other. 2 of them should always be the same. And then we're going to solve for the variable in the third piece. So in order for this to be continuous, we need negative 3 equal to 2a plus 1. Solving for a, we get a equals negative 2. That will make this function continuous at x equals 2. Okay. Take a second. Looks really complicated, but hopefully not really. Let's do the last two problems here. Part E. F of x equals x squared minus 1 when x is less than 3, and 2ax when x is greater than or equal to 3. Okay, so the top piece is to the left of 3, bottom piece is to the right of 3. And we're considering c equals 3, that's where this function could be discontinuous. Limit as x approaches 3 from the left of f of x, it's going to be the top piece. Plugging in 3 using substitution, we get 3 squared minus 1, which is 8. Limit as x approaches 3 from the right of f of x, So that's the limit as x approaches 3 from the right of 2ax. Plugging in 3 for x, we get 3 times 2 times a, 6a. And finally, f of 3, which piece allows us to plug in 3 for x? The bottom piece. So we also get 6a. All right, we have to write out the statement like usual. Continuous if and only if these 3 pieces are the same. So 8 equals 6a equals 6a. Again, like we should, we get 2 are the same. We set them equal to each other. And we get a equals 8 over 6, which equals 4 over 3. That's our answer. Okay. One more. Part F. F of x equals. Ooh, this one looks a little more interesting here. All right, we're considering c equals 3. Top piece is to the left of 3. Bottom piece is to the right of 3. Limit as x approaches 3 from the left of f of x. That means we're plugging into cx plus 1. Substitution, we get 3c plus 1. Limit from the right is the other piece. So plug in 3. 3 squared is 9, so we have 9c minus 1. And then f of 3, it's the top piece here, 3c plus 1. This is interesting because we ended up with a variable in all 3. No, that's okay. Same definition, we know it's continuous if and only if limit from the left equals the limit from the right equals the function value. So we have 3c plus 1 equal to 9c minus 1 equal to 3c plus 1. Set these two equal to each other. Okay, add 1 to both sides, subtract 3c from both sides. So c equals 2 over 6, or 1/3. Pardon me. And there we go. You are officially done with honors pre-calculus. Thank you. I'll have much more to say later this week, but for now, let me know if you have any questions about this, especially those of you moving on to AP Calcul. Definitely need this knowledge again, and I'll see you later. All right, you are all done with math for the school year. It's been a great privilege and an honor. I will see you one final time on Thursday, but until then, just make sure if you haven't, you've finished up your work for all of your classes, and let me know if you need anything. See you later.